Good morning, sir. We can't hear any. I think you are muted.
Hello, good morning.
Good morning, sir.
Good morning, sir.
Yeah, morning. How are you?
Hi, sir.
Okay.
Oh, thank you, sir.
So I hope you guys are doing great.
Yes, sir.
So today, let me start recording so that I can share the recorded session at the end of the day. Just hold on. Okay. Once again, good morning to you all. Today we will be concluding my own part of the course. Remember, I'm taking sampling and sampling distribution. We started 3 weeks ago. At the end of last week's class, I've advised us to go through the first pages of the textbook that I shared with you during FBA 220. So I said I will introduce you to 2 tables. I will introduce you to the cumulative standard normal table, and I'll also introduce you to the student T table. So the cumulative standardized normal table is displayed on the screen. I hope you can all see it.
Yes, sir.
All right. So the next table is on the next page, has been displayed. So I hope you can see that as well. So I've asked you to also locate those tables in your textbook. So I hope you have the textbook by your side, or you have it somewhere that you can always go back and forth and compare, what is being displayed with what you have in the textbook. And I will always advise that you do a lot of practice after the classes. So, so the first one is the Z table. I'll just show you how to check the probabilities in the table, and then later we'll see how we make use of those figures. But how do you just check the table? Now, the table that you have is also known as the Z table. Z table. Z. You can see the Z that I'm circling around here. Can you see it? Z. So that's the second name for it. So either you call it the standard normal table, or you call it the Z table. So which means that if you are computing margin of error, and there is that symbol of Z in there, so that signifies that the table that you'll be making use of is the standard normal table. Now, that table has in its first row decimal places, 2 decimal places as its first row. That is the topmost row. So if you have your Z as minus 0.25, minus 0.25, that means you will trace your Z to 0. That is minus 0.2, and then the second decimal place will make it 5. So 0.2 minus 0.25. This is minus 0.2 here that I'm circling. And then the first value there is minus 0.20. The second one there is minus 0.21. The next is minus 0.22. Next is minus 0.23. Then you have minus 0.24. And then finally, at the middle here, we have minus 0.25. The values inside the Z table represent probabilities. The values under the Z table represent probabilities. In fact, they are actually the values of integrating. You know, when you find the area under a curve, you will integrate from the minimum to the maximum value. So the minimum there is minus infinity. So the maximum value is the Z that we are checking. So if I'm integrating from minus infinity to minus 0.25, the value of that integral is what is in the table that we are checking. So rather than you integrating and start sweating out the calculation, all you just need to do is to check in the table because the values have already been compiled. So the first one here is the value when you integrate from minus infinity to minus 0.20. The second one is when you integrate to minus 0.21. The third one is when you integrate to minus 0.22. The next 0.23. The next 0.24. And then if you are interested in the values for, if you are interested in the values for minus 0.25, and then what you will have there will be 0.4012. 0.4012. So the value of the integration have already been compiled in the table. So we are making use of those values to compute probabilities. So if we are to check for the values of minus 0.2, minus 1.96, minus 1.96. Now let's check it out. Minus 1.96. That means I will look for minus 1.9, minus 1.9, and then to make it to the decimal place, I will check the top column. So where you have 0.6, that makes it minus 1.96. So if you trace it out, the value will be 0.0250. 0.0250. That is minus 1.96. Now let us check for minus 1.64. Minus 1.64. Now minus 1.64 will be Z, you can see minus 1.6, because the column under Z will give you up to 1 decimal place. Now to make it to 2 decimal places, you will now trace it down to where you have 0.4, 0.4, and that will be the probability for minus 1.64, minus 1.64. So if you trace it out, and that will be 0.0505, 0.0505. Now, let us check out minus 2.48, minus 2.48. That means the Z will be minus 2.4. Then to make it to 2 decimal places, I will now trace it down to 0.8. Trace it down to 0.8. And that will be 0.0066. 0.0066. That is the probability for minus 2.48. Now let's check minus 0.05. Minus 0.05. Now, minus 0.05, you know, to the first decimal place, it's minus 0.0. Okay, and then I trace it to where you have a 5, and then you check the value, and that will be 0.4761. 0.4761. That is minus 0.05. Minus 0.05. Minus 0.05. Okay, so that's how to check the table. And let me just do a quick revision. Remember, we have not applied the figures from the table. So I've only showed you how to check it. All right, so that when we get to the stage where we need to get the value from the table, you guys will just understand exactly what I have done. So I said the title of the table is Standard Normal Probability. In fact, it is Cumulative Standard Normal Probability Table. Cumulative Standard Normal Probability Table. And it is also known as the Z table. Also known as the Z table. Now, to make use of the table, you need to get the value of the Z. What you are computing is actually the probability, okay, which is also the same as finding the area under a curve, okay, so which is integrating from minus infinity to that value of the Z. So you don't need to bother yourself about how those values are computed. The values have already been computed and they are compiled. So we are finding the probability that your Z is minus 0.25, minus 0.25. So the value of Z to 1 decimal place is stated in the first column, all right? While the other columns will now make it up to 2 decimal places. So if I want to find the probability that Z equals minus 0.25, it simply means that the first column, which is to 1 decimal place, I will get the value for minus 0.2 and then trace it down to where I have 0.5. And that makes it minus 0.25. So whatever I get from the table will be the required probability. So even if I'm interested in minus 1.65, minus 1.65, the Z column, okay, the first column will give me minus 1.6. Now to make it to 2 decimal place, all I need to do is to trace it to where I have 0.5, and that will give me minus 1.65. So the value that I'm able to get there, which is which is 0.0495. 0.0495 will be the desired or the required probability. So that is how to check the Z table. And I think it's very clear enough. So we'll be making use of it. So like I advised us, there's nothing wrong in you raising up your hand if you have difficulty in understanding any concept. Okay. So once you raise up your hand, I will. So Saka Aisha. So
yes, sir.
Do you have any issue? Yes.
Yeah, I have a question, sir.
Okay, go ahead.
From the bottom, minus 0, minus 1, minus 2, and minus 3 to that minus 9. I don't understand how to check that part.
Minus
Minus
what?
0
Just take
to minus 9.
No, let's take it one by one. The first
Minus
one,
0.
minus 0. If it is minus 0, you can have minus, you can have 0, 0. You know, 0 is unsigned. 0 is neither positive nor negative. So I can have 0.00. So if you check it out, 0.00 is 0.5. Okay? Now, the minus now comes in by the time I'm moving away from 0, either I'm moving to the left or to the right. So for me to check minus 0.0 minus 0.02, that's where the movement away from that first column will make sense. 0.02. You know, the first column that you have will have it as 1 decimal place. So it stops at 1 decimal place. I can only get 0.0. Now to make it 0.02, then I'll move away 3 steps to the right. If you look at the top column, you have it as 0.02. So joining that 0.02 with my minus 0.0, that is minus 0.02. So the probability there will be 0.4920. Okay, so what is the next one?
0.1 minus 0.1.
Minus 0.1, okay? Minus 0.1 without any value behind it. It's simply minus 1.0 minus 1.00 minus 1.00. Now, if you check it, minus 1 point, look at minus 1.0 here, okay? 0.00 is this. That means there's no decimal place after that minus 1, and that is 0.1587. 0.1587. All right. But if it is minus 0.10, you know that is different from minus 1.0. Minus 0.10. This is 0.1. This is minus 0.1 here. Then 0.10 is this. That is 0.4602. 0.4602. Then what's the third one?
Oh, now I get it, sir.
Okay, you understand it. All right.
Yes, sir.
So we have more hands. Yes, Glory, go ahead.
All right, good morning, sir.
Yeah, morning.
Sir, what if you are given 3 decimal places, say 0.035?
Okay, 0.035 into 3 decimal places. Now, the table is to be used for 2 decimal places. So if you have 2 decimal places, you will approximate your value to 2 decimal places before checking the table. So in the case of minus 0.035, if I approximate to 2 decimal places, it gives me minus 0.04. So it is 0.04 that I will check. I will ignore, I will have rounded up to 2 decimal places. So you need to change it to 2 decimal places before checking the table, because the table does not make provision for 3 decimal places.
All right, sir. Thank you, sir.
Okay, so Prince Will.
Good morning, sir.
Yeah, morning.
Last week we stopped at estimation, and I joined the class a bit late. I wanted to know if you started today.
Yes. Yes, you know, for us to do the estimation, we need this table. So I couldn't go ahead because I needed to introduce you to the table, and then we will now go back to estimation. Because when we are computing the margin of error, we will need this table. So that's why I'm taking the table now. So once you understand the 2 tables, then I will go back and start or continue the estimation. And I also remember one of you requested that I go through the errors in sampling. So we'll do that today. But it is better that I put you through the use of the table. Once we are okay with it, then I will now go back and continue from where we stopped. And then we start making use of the values from the table. Oliver.
Okay, good morning, sir.
Morning.
So what if we are looking for a one decimal place? Are we going to use
So one
this
decimal
same
place.
table?
Oh,
Yes.
okay. The one decimal place is stops at the first column. All right. So if I want to check minus 2.9, look at minus 2.9 here. Minus 2.9. Minus 2.9 is the same as minus 2.90. Okay, it's just that it is not written. So to one decimal place, this is just my value, 4.0019. So if I'm to check minus 1.8, minus 1.8. So minus 1.8 is the same as minus 1.80. The probability is 0.0359. And then I must call your attention, everyone. Please note that the table is from -3 to +3. I did not add the second part on this slide. But if you check your textbook, so you will see there that the standard normal table ranges from -3 to +3, right? So -3 to +3. So depending on what you are checking, you can always check your table. So what is important is you should know when to check it. So someone is asking, which textbook? The textbook that I shared during the FBA 220 class. I shared the e-copy, and the class governor confirmed to me last week that you all have it. So just go back to your group chat. I'm sure it's still there. So just download. Glory. So
Yes,
I'll
sir.
take this as the last question, then we'll move to the next table. So Glory,
Okay.
go ahead.
So I said the standard normal table is range from -3 to +3. So this one that we are
Yes.
seeing presently, is it range
Yeah,
from
this
-1
it's
to
from -3.
-3?
No, this one starts from -3 to 0. If you check, look at the top. Have you seen it?
Yes, sir.
It's from -3, and then it stops at 0 here. So, but however, the next one will be the other side of it starts from 0 to +3. From 0 to
Okay,
3.
sir. But I can't see your screen.
So we can't see your screen anymore.
I'll share. I think there was a network issue on that device, so I will log in again and then continue. Just hold on. Let me log in to the other device. Okay. Adetono, we're trying to get the clarification.
Yes, sir. Yes, sir. I just wanted to have a quick question. So this table, sir, is it perhaps that probably during the exams we are going to like have them, or we have to like memorize them?
No. The tables, if you need it, the table will be provided in the exam. So either as a page on the question paper, or the extracts that you need provided in figures. So not that you need an external material. And then if you need to get a copy, maybe you need to make photocopy, we will let you know. So let's move to the second table that I'm introducing before we continue with our estimation. So this table is called the student T table. The student T table. So sometimes it's just simply called the T distribution table, right? The T distribution table. The scientist that developed the table, his name is Student. So that's why it's called the student T table. So the table requires two parameters. It requires what we call the degrees of freedom, and it also requires what we call the level of significance. So the degrees of freedom is on the first column. The first column, the degrees of freedom is on the first column. And then the level of significance is on the first row. Can you see it where you have it from 0.2, 0.1, 0.05, 0.025, 0.01, 0.005? So for you to check the table, you'll be given the value of the degrees of freedom and then the corresponding value of the level of significance. The level of significance there is known as alpha, all right? So that alpha will be given. All you need to do is to bring out the values from the table. So for example, if I've given you a degrees of freedom of 5, all right? And the alpha is 0.025. So all I needed to do is to trace my degrees of freedom to 5, as we have here, and then I will check under 0.025 here. So, and that will be 2.571. 2.571. Let me take it again. I said the table requires the use of two parameters. You'll be required to check the degrees of freedom and then trace it to your significance level. Your significance level is also known as alpha. So that value of alpha will be given, the degrees of freedom will also be given. So if I have a degrees of freedom of 7 and my alpha is 0.1, so all I need to do is to trace my degrees of freedom column to 7 and then check the alpha to be 0.1, and the value there will be 1.415. 1.415. Now, what if the degrees of freedom is 65 and my alpha is 0.01? 65 and my alpha is 0.01. Now, I have traced the degrees of freedom here, 65, and then I look for 0.01, not 0.1, no, 0.01. Now 0.01 is here, and that is 2.385. 2.385. Okay, so let's take it again. I said the table is called the student T table, or simply put as T distribution table. That for you to check values from the table, you need two parameters. You need what we call the degrees of freedom, and you also need what we call the significance level. So if you are given the degrees of freedom, maybe 4, and the significance level of 0.05, all you need to do is to trace the degrees of freedom to 4, as we have here, and then move it to 0.05. And then whatever you see there is your T value. So in this case, degrees of freedom of 4 and alpha level 0.05, it is 2.132. 2.132. Now, then what if the degrees of freedom is 91? Degrees of freedom 91, and our alpha level is 0.005. 0.005. Now, what will you do? Go to 91 and then trace it. Trace it on 0.005. Look at the value. The value is 2.631. 2.631. Degrees of freedom 91. Our alpha level is 0.005. So I hope this table is clear enough in terms of checking it and then retrieving values, getting the two parameters, and then values. So now let's apply it. Let's go back to estimation, and then we'll see how important these tables are in getting our estimates. So I will start from the errors, going by the concern that one of you raised, that I didn't discuss errors in sampling. I just moved straight to sampling with or sampling without distribution, without replacement. So I promise that I'll just quickly go through the errors and then come back to estimation. Okay. Now, remember that during the course of our sampling, that I emphasized that the whole essence of sampling is to estimate the value of the unknown population parameter. So the parameters are not known, and that's why you needed to take sample from it so that you can have an idea of that population. Now, while you are trying to estimate, I mean, taking sample, observing it, and then generalizing, you could end up committing some errors. So there are two types of error that you can commit while sampling. Two types of error you can commit while sampling. Don't worry, the networking is affecting the other device, but I will log in again any moment. But meanwhile, I can be explaining while making an attempt to share the screen again. So while you are taking your sampling, you are liable to two types of error. So we have sampling error, and then we have non-sampling error. Those are the two types of error that you are liable to. Okay. So when you say sampling error, it means that error that you committed as a result of the sampling technique that you have chosen. I will take it again. That while you are taking sample from your population, in order to have an idea of that population, in order to make judgment about that population, you are liable to two types of error. The errors are sampling error and non-sampling error. Now, sampling error, they are error that arise as a result of the technique that you have chosen. Okay, so and arise when you have not chosen the the right technique, and when your sample is not is not reflecting the population that you have taken. Okay, so you are looking at the weight of ladies, for instance. All right, maybe I have some product. We are moving towards Christmas, and there's a product that I want to market to 300 level FBA students. Okay, and I deal with female wears. So, and I wanted to have an idea of the size of female in the faculty so that I can bring in my product. But when I selected female as random for me to have an idea of their sizes. So if I end up selecting only the slim ones or only the very big ones, you know, that sample will be biased because it doesn't reflect. That is, you know, the population of the ladies in the FBA 300 level are not necessarily thin or are not necessarily big. So if I don't do my selection well, I will get a sample that is not reflective of that population. So that kind of error is sampling error because the method that I use is not leading me to the desired result. All right, so that's sampling error. Then the other error, which is the non-sampling error, there are errors that are due to other reasons apart from the sampling technique that you have chosen. So it could be that the measuring tools that you used is faulty. So it could be that the responses that you get for each of the questions, maybe your respondent misinterpreted some of those questions and then they provided wrong answer. So that's not sampling because it's not as a result of the sampling technique, but it's just as a result of some technical issues that is outside the sampling technique. And it could also be that the error sets in when you are about summarizing the data, when you are about compiling the data, and then the error, started finding their way into your estimation. So those are the two types of error that you can have when you are sampling. Remember, the first one is sampling error, and then the second one is non-sampling error. Sampling error is attributed to the sampling technique, and you have it when your estimate is at variance. When your sample is at variance with your population, your sample is not reflective of the population as a result of the sampling technique that you have adopted. But the non-sampling error that's drifting into your estimation as a result of maybe measurement error, as a result of non-response, as a result of incorrect responses, as a result of data compilation error, and so on. Those are non-sampling error. Those are the two types of error that you can have. So I hope that addresses the issue of the student that asked that question last week that I didn't look at the errors. So then let's continue with our estimation. All right. So as a summary, this flowchart describes our estimation in brief. Our estimation can be point, it can be interval. I've explained that several times. So when your estimation procedure leads you to a single value, you have what we call the point estimation. That value that you use, that formula that you use to arrive at that single value is an estimator. So that formula is a point estimator. Otherwise, your estimation will lead you to a range of values or an interval, and that estimation is interval estimation. The formula that you used that now leads you to that range of values or an interval, that formula is interval estimator. Remember, the difference between estimation and estimator is that estimation is the procedure. Estimator is the formula that you eventually used. Now, Now let's look at this simple scenario here. So this example, it says that suppose someone asks you how long it takes to go from Akoka to Victoria Island. You know, it is possible for you to say that it is 30 minutes. Okay, that's an estimate. That is point estimate. And it's also possible for you to say, it will take me between 25 and 40 minutes. So that's also an estimate. That is interval estimate. All right. So that's a typical example of how you can describe point and interval estimation. So so let's see how we can apply the estimator. Now, look at the screen, the margin of error. The margin of error is added to your estimate to give you the upper bound. The margin of error is subtracted from your estimate to give you the lower bound. So, which means that if you are constructing confidence interval, the difference is that you have your target estimate plus or minus the margin of error. So when you add the margin of error to it, it gives you the estimated upper bound. When you subtract the margin of error from it, it gives you the estimated lower bound. Joy. Joy.
Yes, sir.
Yes, you have the floor. Go ahead.
Sir.
Go ahead, ask your question. Yes. I'm listening.
Sir, can you repeat this?
Wow, your voice is cracking. Maybe you just send it as text. I'll get it.
Okay, sir.
Okay, sir. Sir, please, can you help us explain the margin of error again? I didn't get the explanation.
Yes. So, I'll go back to our point and interval estimation. You know, the point estimation will lead you to a single value, and then the interval estimation will lead you to a range of values. Now, what is the difference? In the point estimation, you have the estimates or the target value or the average or the mean that you are calculating, while the interval will add some margin of error into it such that it will accommodate the it will accommodate the tolerated margins between what you have expected and what you observe. That margin of error is computed as your standard error times the value from the table. Either you use Z or you use T. The standard error is your standard deviation all over the square root of mean. So when you, all over the square root of the sample size. So when you find and then you multiply with the value from the table, it gives you the standard error. Don't worry, we'll compute it now. I will show you. So that margin that differentiates, that margin that allows you to have some freedom, you know, is your margin of error. So if you add that margin of error to the mean, it gives you the upper bound, the highest possible value that you can have. When you subtract that margin of error from the mean, it gives you the lower bound, the minimum possible value that you can get as your estimate. So that margin of error would will give you the will allow you to compute the value of your confidence interval. Now look at this flow chart. It explains everything about estimation. Now, when do you make use of the Z table, the one we call the standard normal table, and when do you make use of the T table, the one I call the student T table? Now, it all depends on whether the standard deviation of your population is known. When the standard deviation is known, now look at what we have on the right, on the left. It says we use Z. Can you see Z alpha over 2? X bar plus or minus Z alpha over 2.
No, sir.
We can't see your screen.
We can't see your screen.
Oh. Don't worry. The network thing has come again. I will
See the screen, sir.
I'll share. Just hold on. Just hold on a bit.
Joy, please mute your mic, please.
Okay, the screen is back, right? You can see it.
Yes, sir.
Yes, sir.
Yes, sir.
So let's go back.
Yes, sir.
So I said this flow chart explains the detail on how or when to make use of the Z table and when to make use of the T table. Now, the population from where you're taking your sample from, if the standard deviation is known, you will make use of the Z table. Now, how do you know that it is Z? Look at what you have at the left. Z alpha over 2 times sigma over root n. Can you see it? X
Yes,
bar
sir.
plus or minus Z alpha over 2 times sigma over root n. Now, this margin of error, the margin of error is the Z alpha over 2 times sigma over root n. Now, sigma over root n is called the standard error. Standard error. Sigma over root n is called the standard error. Now, by the time you multiply with Z alpha over 2, Z alpha over 2 is the value that you obtain from the table. That value that you obtain from the standard normal table is the Z alpha over 2. If you multiply the 2, then what you have is the margin of error. Now, that margin of error is added to the mean to give you the upper bound, that is the highest possible estimate. It's also subtracted from the mean to give you the lower bound, which is the lowest possible estimate. So that when you are making a statement, you could say that your estimate, the value that you are computing for the population parameter, lies between the lower value and the upper value. So I can say that the time taken for me to get from UNILAG to VI is between 25 and 40 minutes. Because I'm saying that when the road is free, it will take me 25 minutes. In the worst case scenario, it takes me 40 minutes. But I could also give a definite value and say From here to VI will take just 30 minutes. So I'm still doing estimation. So in the first scenario, I've decided to be careful because I'm not so sure of what will happen on the road. I've given the lowest estimate and the highest estimate. But the second scenario, I'm so definite and I wanted to be, I'm certain. So I decided to place a value on it and say, look, in 30 minutes time, I can be in VI. So those are two possible ways that you can state it. But when do you make use of the Z? When do you make use of the T? When the population standard deviation is known, you use the Z. When the population standard deviation is unknown, you will need to estimate the Z. That's what you have on the right. You will need to estimate that sigma, estimate it with S, and then you compute the margin of error after getting the value from the T table. Remember, the T table there is the T alpha over 2. So that is the critical value. You use it to multiply the standard error. The standard error there is S over root n. After multiplying the 2, I will arrive at what I call the margin of error. Please note all this, because I will share a link with you where you will have your assignment 1. So this will improve your chance of doing well in the assignment 1. And I will also share some videos with you. Watch them and get hints on how to answer some of those questions. So now let's apply. Let's apply these two possible formulas, sigma known, sigma unknown, to doing our estimation. Please feel free to ask a question.
Sorry, sir. Please, can you the formula down there? Is it the margin error formula or the Z formula?
Okay, I'll take it again. Look at what you have on the screen. You see that sigma over root n. That sigma over root n is called standard error. The sigma over root n is called standard error. Now, when you multiply that value with Z alpha over 2, this alpha over 2 is what you get from the standard normal table, the very first table that I introduced when I started the class. So whatever you have there, if you use it to multiply the standard error, you end up getting the margin of error. Margin of error. That's what you will get. Margin of error. Okay, that's what you will get. So that margin of error, or you call it error margin. So that error margin is added to the mean to give you the upper limit. It's also subtracted from the mean to give you the lower limit. This formula, X bar plus or minus Z alpha over 2 times sigma over root n, is the estimator for our interval. So it is interval estimator. Interval estimator. All right. So Z alpha over 2, we will obtain it from the standard normal table. Sigma, because we say it is known, will be given. And then root n. N is the sample size. So when you find the square root, use it to divide. That gives me standard error. This is standard error. Z over sigma over root n is called the standard error. Standard error. Please, so in that assignment 1, all these are there. Don't make mistake. Start accumulating your grade now and make sure that you do very, very well. So standard error is different from margin of error. or different from error margin. Standard error is sigma over root n. Error margin is now when you multiply standard error with the value from the table, it now gives you error margin. So you should note that. So this is the confidence interval when you are estimating the population mean and the sigma is known. All right, so this is the formula to use. Now let's apply it. Look at the question. A department store wants to determine 95% confidence interval of the average amount spent by all its customers. That's the objective. And then the store took a sample of 100 customers and found that the average amount spent is 82,000. So the question is, you should estimate, but that's what the objective is, the first bullet. So you have to estimate the average amount spent. That is construct the confidence interval for it. That means you will state the minimum amount spent and then state the maximum amount spent. So that gives you the range of amount spent by the customers in that particular department store. Now look at the solution. The formula is x bar plus or minus z alpha over 2 times sigma over root n. So the sigma is known, 20. It is given in the question. The population standard deviation is 20. 100 customers have been selected. Our n is 100. It's also given in the question. And then we're also told that out of that 100 selected, the average amount spent by them is 82,000. And that's why you have the 82 here. There's nothing difficult about it. So the next is, how do you now check the value to get 1.96? Now, the probability is given. The probability is given. 95%. 95% is the same as 0.05 as the level of significance. But if you check the formula says Z alpha over 2. Alpha over 2. So if alpha is 0.05, 5%, if you divide it by 2, what will it be? 0.025. 0.025. Now, your job is to look for the value of Z that corresponds to that 0.025. Now, if you check the table, you will see that it is 1.9 under 6. Go and check it. This minus 1.9 under 6. You will get 0.025 there. So there are some hands up. Atalo, blessing.
Morning, sir.
Morning, yes. Ask your question.
So in your solution, you are giving this standard error. You are giving 20, but in the question, there's no 20. You said the standard is 20, but in the question, there's no 20.
The standard deviation.
Population standard is 20.
You know, you can see that there's a cut here in
Okay.
the second bullet.
Okay, sir.
So there's a cut there. So I will share the PowerPoint. But while converting to PDF, you can see that there's a cut here, assuming that the population standard deviation, there's another wording under. Assuming standard deviation is 20. It's actually provided. I'll share the complete question after. Adeife.
Good morning, sir.
Yeah,
Regarding
morning.
the Z alpha divided by 2, you said 0.05. How did we get it?
Okay. You see, 95% confidence translate to 5% error. You know, if you say that you are 95% confidence of something, you are indirectly saying that you are 5% not sure of it. So 95% confidence is the same as 5% margin of error, 5% error. So alpha is 5%. So 5% is the same as 0.05. So when you divide it by 2, as you have in the formula, Z alpha over 2, it is the same as Z 0.025. Z 0.025. And what you are saying there is that you are looking for the value of Z that will produce a probability of 0.025. And that value of Z is minus 1.96. Ayomide?
So that is the same question I want to ask, sir.
All right. Oladipo. Oladipo. Okay, Ibrahim.
Yes, sir.
Yes.
Sorry, sir. In the question, we were told that the average amount spent is 82,000, but in the solution, 82 that is written.
The average amount spent is 82,000. 82, look at it on the screen. Can you see it?
If
yes,
the Z table is 2 decimal points, would that be 0.03?
You said? If? Go ahead, ask your question. That lady was talking.
Yes, sir. So she meant the answer is 0.025, that we have to approximate to 0.03 before we check it.
No, 0.025. 0.025 is a probability that is given. You are not checking the table for Z is 0.02 under 5. No, that probability is already given. That 0.025 is the probability. That means it is inside that table. You are only looking for the value of Z that will produce that probability. That's the difference here. So if you check minus 1.96, you will see that minus 1.9 under 6. If you check the probability, you will see 0.025 there. And that's why in the calculation, there's 1.96 here. Okay, that's the value of Z that will produce that probability. So from our estimates, you can see that the amount spent is actually between 78 and 85,000 in that particular departmental store. Etin. Okay, so so you can see the
Excuse me, sir.
Yeah, go ahead.
Yes, sir. Sir, I didn't understand the explanation you gave for that example, sir.
Oh, okay. Now look at what you have on the screen. So we got 78 as the lower limit. That is after subtracting 3.92 from 82. And then we got 85 as the upper limit after adding 3.92 to 82. Now look at the explanation there. It says that the average amount spent at the department store by customer is between 78,000 and 85,000. So which means that customer that goes in there spend minimum of 78 on the average and maximum of 85. That's the interpretation of the confidence interval. If I had computed and I arrived at just one single value based on the formula that I use, I'll just simply say that the average amount spent is maybe 82,000. But because I've constructed confidence interval so that I have my lower limit and the upper limit, I could say that the average amount spent is between that lower limit and the upper limit as computed. So the table used, yes, go ahead.
When I went through the table, the 0.025 was found under minus 1.96, but euro positive 1.96. Why?
We are checking it. Now look at it here. Minus 1.96. Have you seen it?
Yes.
So remember, it is plus or minus. Plus or minus. So when it is plus, it's minus 1.96, right? When it is minus, it's plus 1.96. Do you agree?
I don't get it.
The table, the formula is plus or minus Z alpha over 2. So when it is plus, it will be minus 1.96, right?
Yes.
You know it is plus times minus.
Yes.
And when it is minus, what will it be to be plus?
Yes.
And the two have been taken care of. So the two have been taken care of. I hope you understand.
Sir, please explain that again.
Let's go back. Now, look at the screen.
How do you get the 82?
Look at the screen. Z alpha over 2, we got it as minus 1.96, right? But there's a sign here of plus or minus. Is that not it? So
yes,
if I bring in that minus 1.96, if I plug it in here, I will still end up having my plus or minus. Because when I have the plus, multiplying the minus 1.96, I will have minus 1.96, right? And then if I have the minus times 1.96, I will have this as plus.
Okay, yes.
Sorry, sir.
Yes, ask your question.
So how did you get 0.0250?
Yes. Well, how did you get it?
That's what I'm asking you, sir.
Remember, the confidence interval, 95% confidence interval, is the same as 5% error, 5% margin of error that you are tolerating. You know, if you are confident, if you are absolute confident, that will be 100%. But if you are 90% confidence, you are only leaving 10% for error, right?
Yes, sir.
So in this case, the question has stated that you are 95% confident. That means our error is 0.05. That is 5%. 5% is 5 all over 100, and that would be 0.05. But the formula says Z alpha over 2. Alpha is 0.05. That's the margin of error. If you divide it by 2, that gives us 0.025. That's where it's coming from, 0.025. So your job is now to check the table. What value of Z will produce 0.025? And that's where we got the 1.96 from. As you can see, I'm hovering around 0.025.
So that's to say, sir, that 0.025 is a constant.
No, 0.025 is the probability. Okay, you are using it to now trace back the Z that will produce that probability.
Okay, sir. Thank you, sir.
Sir.
Yes. Go
Sir,
ahead.
does that mean that the 1.96 that we are going to, the minus 1.96 that we are going to add to the 82,
Yes.
does that mean that the upper limit is going to be lower than the lower limit?
No, the upper limit here is 85 now.
Since that negative sign will change, because you said to get the upper limit, it is the 82
check the screen.
1.96, but it is
check
minus 1.96.
Okay, so check the screen now.
I'm seeing, sir.
The upper limit is 82 plus. So that gives you 85. The lower limit will be 82 minus, and that will give you 78.
But what we got from the table originally was minus 1.96.
Yes. When you get minus 1.96, and you plug it in where you're supposed to have Z alpha over 2, that the plus or minus sign will remain unchanged. That's what I was proving. I was proving the other time. The plus or minus sign will remain unchanged. Because if you plug it in minus there, the minus will make it to be plus. Do you get it? And then the minus will make it to be minus. So it is still plus or minus 1.96.
Okay, sir.
Okay, sir, excuse me, sir.
Yes, go ahead.
You said to get the upper limit is by adding the margin of error to the mean. So the margin of error, when we add the upper limit, when we add, we are going to the margin error for the upper limit give us a negative sign. So does that mean 78.08 is the upper limit?
No.
Or what do we count as the upper limit and lower limit? Is it the lowest value after the calculation that we?
No, the upper limit is obtained by X bar plus the margin of error.
So yes, I understand.
Then
When I did that,
the lower limit is X bar minus the margin of error. So the question is, what is your margin of error? Your margin of errors will simply be 1.96 times your standard error. So I've already proven to you that that plus or minus that you already had, I was taking care of the minus that you got from the table. You don't worry, by the time you get home now, or when you are relaxed, you understand what I'm talking about. And you are still free. When we meet again, you are still free to bring it up if it's still creating some confusion.
And those are.
But it's clear.
Sir.
Yes, go ahead.
Yeah, I want to ask question concerning the Z0.025. Since we have the probability, we have the probability now, I think having the 1.96 is better than having the probability, because in exam now I have to go and be looking for 1.16 that can produce probability of 0.25. Why can't we just get the 1.96, then me just looking for the probability? Is there a way I can get the, like, what is the probability of 1.96 from the question? I don't know if you get me, sir.
You know, I said that in the exam, there are two possibilities. As part of your questions, we can add the table to it so that on your own you can check and then put in the values. And I also said that we could also provide you that value and say that given that Z alpha over 2 is 1.96, so we can use any of the two. So what you should try as much as possible is to ensure that you know how to check the table.
Okay, sir.
So if we provide you the value, fine. If we ask you to check the table yourself, you should also be comfortable with it.
Okay, sir.
So and then the other follow. So you can work on your own and get others. So as being presented in the material that you have. So ladies and gentlemen, I'll stop the class now. I will encourage you to please attempt all the questions. We gave you video, please watch. We don't want anybody to score low marks out of carelessness. So please try as much as possible and do yourself a favor by doing very, very well. Yes, someone is asking a question. Yes.
Hello, sir. So you
Yeah,
asked
go
us to
ahead.
do something on that main stuff that I said that you are going to explain it. Like we should and just like you said we should go and do it, that you are going to explain the difference without replacement and with replacement.
The sampling without replacement. Where
Yes,
I
you are
said
going
I think I ended up opening a Word document and then start doing some stuff. Go and check the video.
Okay, sir.
Yes,
When I
sir,
discovered that you
did.
guys were having difficulty, so I opened a Word document and then I demonstrated how you can have 10. So please watch that video. All right, so I will close the class for now. So I wish you all the best. Bye-bye.
Thank you.
Thank you, sir.
Thank you so much,
sir.
sir. Thank you, sir.